Permeable pavers are brick-like structures that can support tremendous weight while allowing rainwater to seep through them and into the ground. Conventional pavement allows rainwater to run off, which puts stress on municipal stormwater systems by compounding water quality problems such as flooding, water pollution, and damage to aquatic life. There are 5 standard types of permeable pavers. The most basic type of paver uses freestanding bricks, concrete blocks, or flat stones laid on a bed of sand and stone aggregate. Of the pavers, freestanding are the least stable and are only recommended for infrequently traveled or light load-bearing areas. A freestanding paver structure should be designed so that the pavers are elevated relative to the surrounding landscape. Elevating the pavers prevents soil and sediment runoff from collecting on the pavers, which may cause clogging. A base and bedding layer provide the foundation for the pavers. The depth of the base layer and bedding layer depends upon the volume of water that needs to be collected. Deeper base and bedding layers allow greater amounts of stormwater to be collected and infiltrated into the subsoil. A paver design in which vehicular traffic is not expected may only need a bedding layer of 2 inches of clean sand. Where significant foot or occasional vehicular traffic is expected, an 8-inch base layer of 1.5 inch to 2.5 inch diameter stone aggregate should be installed between the subsoil and the bedding layer. As with conventional paving, lay out the surface dimensions of the structure using string and framing to ensure the project is both level and contained. Compacting soil reduces its ability to allow water to infiltrate and defeats the purpose of installing permeable pavers. Therefore, excavation must be performed without using heavy equipment on the site where the paver system will be installed. If using a base layer, spread at least an 8-inch layer of 1.5 inch to 2.5 inch diameter stone aggregate over the leveled subsoil base. The void or airspace between the stones will then be able to store about 35% of the total stone volume with stormwater. This base will also provide structural integrity for the pavers. The layer immediately above the base layer or below the pavers is the bedding layer. This layer of sand provides the final leveling bedding for the pavers. The airspace or voids between the sand particles will also store and infiltrate stormwater passing through the pavers. After leveling the bedding layer, use standard bricklaying techniques to place the bricks, concrete blocks, or stones. Pack the pavers close together for greater stability. The next step is to cover the pavers with a thin layer of sand and sweep the sand into all of the spaces separating the pavers. Continue adding sand and sweeping until all of the spaces are filled and even with the top of the pavers. Rinse the paver structure to settle the sand. Check once again to ensure that the pavers are level and add sand to the spaces as needed. Repeat these steps until the structure is stable and ready for use. A more sophisticated form of permeable paver is the Permeable Interlocking Concrete Pavement, or PICP. PICP comes in many shapes and colors and are designed for everything from parking lots and driveways to walkways and nature trails. PICP is comprised of a layer of durable concrete pavers separated by joints filled with small stones. The joints are interlocking shapes that vary from simple notches to built-in concrete joint spacers. The blocks themselves are actually impervious. However, the joints allow for water infiltration. These pavers tend to be more costly than freestanding pavers, but their durability and aesthetic design have made PICP the most popular type of permeable paver system. The construction methodology is similar to that of freestanding pavers. Since these pavers are generally intended to support vehicles, the base layer is critical. Rather than sand, PICP generally uses 1/8 inch diameter stone to fill the spaces between the pavers. Additionally, because interlocking pavers are more difficult to install than freestanding pavers, an experienced contractor is recommended. The third type of permeable paver is the concrete grid pavement, or CGP. CGP is an extensive concrete grid unit that uses large spaces filled with stone aggregate or sod. The reinforced concrete structure provides stability for vehicle traffic, and the gravel or sod-filled spaces provides permeability. A feature unique to this paver is that vegetation is allowed to grow within the structure. The benefits are both environmental and aesthetic. While the installation techniques are similar for base and bedding layers, an experienced contractor is generally required to manage the grid layer. The fourth type of permeable paver is pervious concrete, or PC. When installed, pervious concrete looks like conventional concrete. However, it allows rainwater to flow through it into the bedding and base layers for infiltration into the ground. Pervious concrete is Portland cement with the use of sand or fines. By using a water to cement ratio of 25 to 35%, a thick paste is created. The paste is then used to form a coating around small stones, generally about 1/8 inch in diameter. The result is 15 to 25% void or air space within the concrete. For example, mix 600 pounds of Portland cement ASTMC 150, 27 cubic feet of number 6 stone 3/4 of an inch in diameter, and 30% water to cement mix. The proper amount of water varies considerably, but getting the right mix is critical to the success of the permeability. If mixed properly, a handful of pervious concrete formed into a ball will not crumble. Too little water and the ball will crumble. Too much water and the concrete loses its void structure. The installation of pervious concrete also requires the standard practices of excavation, leveling, setting out the form frames, laying a base layer of aggregate stone, and a bedding layer of sand. Because pervious concrete shrinks less than half the amount of normal concrete, pervious concrete does not require joints. However, many installers place joints every 20 feet as a precaution. Joint tools should be used rather than sawing the concrete. Sawing pervious concrete may cause raveling of the concrete stone, resulting in damage. Another difference between pervious and conventional concrete is curing time. Pervious pavement needs about 7 days to cure. This requires covering the entire surface with plastic, otherwise the surface will dry out too quickly and the paste will deteriorate. The fifth type of permeable paver is permeable asphalt or PA. This is an open-graded asphalt pavement that does not contain fine aggregate particles. This allows void air spaces to be created in the mix and allows water to drain through its surface. Installation should not occur during rain or over a frozen base material. Permeable pavement works best on level ground. Manipulate the site so that no stormwater drains onto the pavers from the surrounding landscape. Be careful not to spill toxic liquids onto the permeable pavement because they will infiltrate into the soil and groundwater. Permeable pavers work best if the structure's base is at least 3 feet above the high water table. If the high water table is within 3 feet of the base, then an under-drain pipe may need to be installed in the base layer to drain excess water to another stormwater device. The under-drain prevents standing water on the paved surface when the soil becomes saturated. While it may be more expensive to install permeable pavers rather than conventional surfaces, cost increases are offset by decreased stormwater management costs. Similar to the RiverSmart Homes program, if you choose to install permeable pavers, then financial assistance may be available through the District Department of the Environment.